Here is how to understand vector spaces in 3 minutes. So before we start, there is actually a few fundamental steps that you must know before we can understand vector spaces. Number 1 is to play Wordle. It's a good brain warm-up game, and if you don't get the word, you're a loser. Number 2 is to normalize long showers, to take long showers, because it'll help you relieve the depressing stuff when you don't understand. Useful and understand. Okay, and the last one is connected to fundamental math. Here's what I mean. For example, when I learned linear combinations, I was thinking about it this way. So in algebra, we learn that we don't learn that 1 plus 1 equals 2. We learn that 1 plus x equals 2, and then x equals to 1. So in linear combination, I was thinking that the absolute value of x plus 1 equals 2. X is either 1 or negative 3, which is sort of like the linear combinations of ax equals b. So now you can finally understand vector spaces. And if you're like me and you didn't know what's going on, we're on the same boat, so that's good. But let me start off by giving you the 8 conditions of the vector space. We'll just say VS for short. Number 1, we have to apply the fundamental laws first. Remember, I told you that's fundamental math. So the associative and the commutative properties still apply to vector spaces. Number 3 is that there is a zero vector. There is a zero vector is included in the vector space. Number 4 is that for each x, there's a unique vector. And then number 5 is that 1 times a vector x equals to vector x. So yeah, fundamental laws again. Now we get into a little more specifics. We have vector C1, C2, or matrix, and then we apply it to x. It's the same thing as C1, C2, and x. C7, we have vector C, or matrix C, x plus y equals cx plus c. Number 8, and that is C1 plus C2, x equals cx. So just vector space is like a circle. Anything within the circle, you can call it a vector space. Now, we have to denote something. In here it says, if I say A is the weird-looking E, that means the element of. And that's kind of important. And we could say that, we denote vector spaces as a real number notation here. And if we say R of 2, that means there are 2 rows, so that means there is A1 and A2. And if there's R of 3, that means there's A1, A2, and A3. And you can think of this as like the second dimension, the third dimension, and there's Rn, and there's infinite many dimensions again, blah, 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 blah. Now there is a special vector space, so-called the null space. But I mean, that's not the point of this video. But I have to tell you that there is a vector space called Z that only contains 0 vectors. And like I said, later on you'll encounter more stuff with vector spaces, but basically, if it doesn't satisfy one of the 8 conditions, then you cannot call it a vector space. Now, a subspace, let's just say a vector space is a circle. A subspace is another circle within the vector space, but we will learn later about this later. So thanks.